Okay, so this next lesson is going to continue a little bit with proofs. We're going to continue to add new material to our sort of repertoire of information that we can use for proofs. And this is going to get us talking about angles now. So we're going to be proving angle relationships. So D is considered to be in the interior. So here's D. It's considered to be in the interior of angle ABC. If and only if the two smaller angles, when you add them together, they make the larger angle of ABC, which makes sense. So again, what that would mean is that x plus y would then equal the bigger angle, which is ABC. So if we look at example 1, if we put actual specific numbers to it, so it says find the measure of angle 1, so don't know that. If angle 2 is 56, but JKL, so this big angle right here, the whole entire thing is equal to 145. So if you know the whole entire thing, but you don't know one of the smaller pieces, that would be considered a subtraction problem. So we're going to say, if we write it out in a general case, angle 1 plus angle 2 equals angle JKL, and fill in what we know. So angle 1 we don't know, so that's going to stay. Angle 2 is 56. And JKL is 145. And then we're going to subtract the 56 on both sides. And when you take 56 away, you end up with 89 for a final answer for that. Okay, the two theorems, we're now going to talk about the supplement theorem and the complement theorem. So supplement sort of has the word supplementary in it, which means 180, so there's a connection there. But the supplement theorem says if you have two angles that form a linear pair, then they are supplementary angles and they add up to 180. Makes sense. So two angles that are next to each other that form a straight line then add up to 180 degrees. So here's angle 1 and here's angle 2. So angle 1 and angle 2 make 180. For the complement, same exact idea. It's just they add up to 90 degrees because they're going to make a right angle. Okay? So if we look here with number 2, we have 6 and 7. They form a linear pair. So again, linear line meaning 180. Angle 6 is 3x plus 32. And angle 7 is 5x plus 12. Now, if they form a linear pair, by definition, that means that angle 6 plus angle 7 equals 180. So angle 6 is 3x plus 32. Angle 7 is 5x plus 12. And it equals 180. Combine like terms. Then we're going to subtract the 44 over. And then we're going to divide by 8. We get x to be 17. Now we're asked to find three things. We need to find x, angle 6, and angle 7. So x we found, 17. Angle 6, what we have to do is take that 17 and sub that in. And we get 83. And 7, same thing. Take that 17 and sub it in, and we get 97. And the nice thing is you want to double check yourself, because if we're saying that these two angles form a linear pair, when you add the 83 and the 97 together, they should in fact total 180 degrees. All right, two theorems on the bottom before we start to practice more with proofs with this. So we have the complement supplement or congruent supplement theorem that says angles that are supplementary to the same angle or to congruent angles are congruent. So for example, if angle 1 plus angle 2 equals 180 and angle 2 plus angle 3 equals 180, well, if you look at those two statements, you notice that they both have angle 2 in common. So if you're adding two different angles to the same angle, which is angle 2, and the total is the same number, then you can conclude that angle 1 is congruent to angle 3. Because you're adding the same item to each of those numbers, and the sum is the same. So that means those two numbers had to be the same. Whereas with the complements, we take the same idea, it's just, again, we're just focusing on 90 degrees. So if we look at 3 plus 4 equals 90 and 4 plus 5 equals 90, well, both of these statements have 4. So if you're taking two numbers, 3 and 5, and adding it to angle 4, and they both equal 90, then we know that angle 3 is congruent to angle 5 for that. All right, so let's practice some theorems here, or some actual two-column proofs, sorry. All right, so we're going to do 3 out of these 4. We're going to skip this guy down here for right now. All right, so we need 2-column setup. We've got our thing there. We know what our line 1 is, so again, that should just be automatic at this point. First statement, we're copying what it says next to the given. First reason is always given. Okay, and then in a previous lesson, again, if we are looking to prove that angle 2 and angle 4 are congruent to each other, well, we know they're vertical angles. I'm going to show you the long way of doing it now, and then there's going to be a shortcut way. So if we look at this diagram, we have a diagram. We see this right here. Well, that's a straight line. So I know that angle 1 plus angle 2 equals 180 degrees. Okay, if I do the same on the other side, angle 3 plus angle 4 equals 180 degrees. And what that means is that is the definition of a linear pair. Okay, the thing though is I can keep adding more of these statements to what I have. So let me actually erase 3 because I'm not quite done yet. And what I'm going to do is, instead of looking at where I drew the red line, I'm going to now draw a second line. And that line, let's say, can go right here. Okay, and I'm going to continue adding as many of these equals 180 statements as possible. So 1 and 2 make 180, but not just 1 and 2. We also have 2 plus 3. And not only do 3 and 4 equal 180, but so do 1 and 4. So I have 4 statements. I basically worked my way around that circle there. And any of the 2 that are next to each other, they're going to total 180 degrees because they form a straight line. Okay, so now if we get back to what we're looking at here in terms of our statements. If I say look at, say, the first one and the last one that we wrote. So 1 plus 2 equals 180, and 1 plus 4 equals 180. So just like we had talked about on the front page, both of those statements share angle 1. So if they both have angle 1 in common, and you're adding something to it, and they both have the same sum, then those other 2 items have to be equal to each other. So we know that angle 2 is congruent to angle 4. If you look at the other 2, the middle 2 guys, what do they have in common? Well, they both have an angle 3. And it's the same idea. You're both adding an angle to angle 3, but the sum is the same, which means those 2 numbers have to be equal to each other as well. So what did we use there? We used the supplement. Let's get proper name here, sorry. Let's call it the congruent supplement theorem. Congruent supplement theorem, and if that name is too much for you, write it out. Okay, you can write, if 2 angles are supplementary to the same angle, then they're congruent to each other. And again, keep in mind, you'll always be given a bank when you do this stuff on any worksheet or assessment or anything for me. So you'll have information to pull from. It's just deciding what you want. Okay, so the nice part about showing you this is because what I'm going to do now is I'm going to show you a shortcut way of doing that same proof, but we know that angle 2 and angle 4 are vertical angles. So this 3-line proof that we just did, it's actually the long way of doing it. So now, on the side over here, I'm going to show you the short way. So I'm going to make a statement side and a reason side. I'm going to smush it. So first statement we know is our diagram. That hasn't changed. First reason is our given. Now, absolutely could you have done what we just did on the left-hand side, but you don't even need to do that because you know that 2 and 4 are vertical angles. And we learned in a previous lesson that vertical angles are congruent to each other. So this also could have been a 2-line proof that just said that angle 2 is congruent to angle 4 because vertical angles are congruent. So you have flexibility, again, two different ways. Usually with proofs, there is always more than one option, so that's the nice part about proofs. You've got to go with what your train of thought is telling you to do with these problems. But you can either have done it this way, or you could have done it this way, because we know vertical angles are equal to each other. All right, let's try two more of these guys. All right, so let's finish the chart. Fill in our line 1, because we know what our line 1 on both sides needs to be. Bisects. And then we have given. Now, another important thing is anytime you're given information, you always want to label your picture. So it tells us that DB, which is right here, it bisects angle ADC. Well, here's angle ADC. Okay, so it bisects that angle. Well, first of all, bisects is a vocabulary word, and we're bisecting an angle. So we're going to write a statement that says definition angle bisector. And what an angle bisector does is it splits it. So if BD or DB bisects ADC, we know that this angle is equal to this angle. So for my statement, I'm going to say angle 1 is congruent to angle 2. Now, for my line 3, if I look at the diagram, I've run out of information to use based on the given. We use the vocabulary word. If we look at the diagram, you notice, just like we had with the previous problem, you have vertical angles here. So you have this angle right here and this angle right here. 1 and 3 are vertical. So we can say that 1 is congruent to angle 3, reason being vertical angles are congruent, just like we had done with the first proof on the other page. And then this is going to use one of our properties from last time or the time before that. But if you look at the previous two statements, these guys, you notice that they both have an angle 1 in common, which means if they both have an angle 1 in common, that is a direct connection. Okay, so what you can do is you can link the other two angles together. So if 1 is congruent to 2, but 1 is also congruent to 3, congruence means equal, which means angle 2 has to also be congruent to 3. And when you have all those congruent statements, that is the transitive property. All right, one final one here. All right, line 1 we know. And I'm going to mark, I know 4 is congruent to 7, so that's my given. All right, so based on the diagram itself, we've got, again, vertical angles. So I'm going to write vertical for my reason. Vertical angles are congruent. And I'm going to say, all right, I know angle 4 is congruent to angle 5. And I know that 6 is congruent to angle 7. So I have two sets. You don't need to write them in two separate lines just because they are the same reason. Can you? Yes. But there's no need to rewrite a second one. All right, so what I'm going to do is I'm going to look at the first two statements. My goal is to prove 5 and 6 are congruent. So I'm looking at these two and I ask myself, okay, well, they have something in common. They have an angle 4, which means if they're both congruent to angle 4, then I know that 7 is congruent to angle 5. And just like we did above, that is my transitive property. Okay, but that is not what my proof statement says. I got to get 5 linked to 6. So now what I'm going to do is I'm going to look at the last statement here and then the one I just wrote. And you say, okay, well, what do they have in common? Well, they have an angle 7. So I'm going to lump the other two together. So angle 5 is congruent to angle 6. And again, that is your transitive property. And if you look back, that is in fact what we are trying to prove. So we got there in 4 lines. Okay, again, transitive, it's not something you